We started with the math equation for efficiency. We started with the math equation to solve for efficiency.
We started with the equation for efficiency.
This is the mathematical solution for vehicle efficiency. Steve and I came to him and said, this is the mathematical solution for vehicle efficiency.
We solved the equation for vehicle efficiency, and that equation looks like the Aptera.
Most automobiles use 60 to 70% of their fuel at highway speeds just pushing air out of the way.
You can burn 60 to 70% of your fuel at highway speeds just pushing air out of the way. Most vehicles on the road today use 60 to 70% of their fuel just pushing air out of the way at highway speed.
We have a very efficient powertrain solution. It's in the wheels. So we don't have a transaxle, we don't have a U-joint, a drive shaft, a U-joint. So you clean up all those losses in your drivetrain.
And then we got a really efficient powertrain with in-wheel motors. The motors are actually in the wheels for this vehicle, so no transaxle, no drive shaft. And when you make it efficient, you can do cool things like it charges really fast. But our vehicle charges, 4 to 5 times quicker than all the other electric vehicles at the supercharger because we use so little energy.
And now with computational fluid dynamics and the ability to run huge simulation on Amazon Web Servers.
And through computational fluid dynamics, we refined the shape of this vehicle such that it looks today. Aggressive engineering, kind of bleeding edge engineering.
We get a lot of pilots and engineers because they just look at this and they're like, this is bleeding edge technology.
It really is.
I want bleeding edge technology.
Well, the Aptera is brutal execution on first principles engineering. When we last tested this body structure, we actually had the highest roof crush strength of any passenger car on the road.
When we last tested the roof crush structure on this, we had the highest roof crush strength of any passenger car on the road.
And we had the highest roof crush strength of any passenger car on the road.
So I want to build the safest vehicle possible to put on the road.
Because we wanted not to just make a safe vehicle, we want to make the safest thing we can put on the road.
But this is actually a carbon fiber monocoque vehicle. It's built much like a Formula One car.
Yeah, this is designed more like a Formula One car, or we've been able to design things in this more like a Formula One car, built very specifically for safety of the occupants than, I think really any other automobile company has been able to do. Built like a Formula One car. And
It's a lot of, using Formula One protection methodology.
Yeah.
Imagine driving to your favorite camping spot that's 200 miles away. You camp for a week. You actually come home with more energy in your car than you left with.
You can drive 200 miles to your favorite camping location, camp for a week, and actually come back with more energy in your Aptera than you left with.
So we want this to be something, I can pass down to my grandkids. I want my mom to drive this. I want, be able to take the kids around in this.
I want my mother to be able to drive this. I want to be able to take my